Hi class, in this video we are going to talk about balancing chemical reactions. So here we have an example of a chemical reaction that is between magnesium and oxygen, right over here. So first rule is we determine the number of atoms for each element. So on this left side, we see we can have one magnesium and we have O2, which is saying that there are two oxygens. And then on the right side, we have magnesium oxide, which is just one magnesium and one oxygen. Step 2 is we pick an element that is not equal on both sides of the equation. So if we look at magnesium, we see on the left side we have 1, and on the right side we have 1. So that means magnesium is balanced. But if we look at oxygen, on the left side we have 2, and on the right side we only have 1. So that means oxygen is not balanced. So we're going to pick oxygen. Step 3 is we add a coefficient in front of the formula with that element and adjust your counts. So we need to pick a formula that we can add a number in front of in order for oxygen to become balanced. So I see that there's a 1 oxygen on the right side, so I'm going to multiply that whole formula by 2. And when I do that, I also have to adjust my count. So instead of having 1 magnesium, I now have 2. And instead of having 1 oxygen, I now have 2. Next, I need to continue adding coefficients to get the same number of atoms of each element on each side. So I look at both of my elements. Now I have only 1 magnesium on the left side. So I'm going to add a coefficient of 2 in front of that magnesium. And now I have 2 magnesium on the left and 2 magnesium on the right, and 2 oxygen on the left and 2 oxygen on the right. That means that this is balanced. All right, so let's try some examples. Okay, so here I have calcium and oxygen, and it's creating calcium oxide. So step 1, I count how many I have on each side. Step 2, I pick the element that is not balanced, which is oxygen. So I add a coefficient in front of the formula, and I adjust my counts. And then I continue adjusting my counts on the left side. So this is a very similar formula to creating magnesium oxide because I'm creating calcium oxide. So it's kind of similar. All right, so here's the next one. We have nitrogen and hydrogen. It looks like on the left I have 2 of each. On the right I only have 1 nitrogen and 3 hydrogen. So here's something interesting. I've got an uneven number of nitrogen on the right side and an uneven number of hydrogen on the right side compared to these even numbers on the left side. Notice that nitrogen has a subscript of 2 and hydrogen have a subscript of 2. That means no matter what I do, I'm going to have an even number of nitrogen and hydrogen on the left side. So a good indicator here of how to balance these is I need to have an even number on the right side. So I'm going to pick the smallest even number, which is just 2, and I'll adjust my counts. So here I have 2 nitrogen and 6 hydrogen, and my nitrogens are actually balanced now. The only thing that's not balanced is hydrogen, so I'll put a 3 in front of that hydrogen, and now everything is balanced. All right, let's do some more. So here we have copper oxide and carbon, and it's creating copper and just carbon dioxide on the right side. So here I have 2 coppers, 1 oxygen, and 1 carbon. And on the right side I have 1 copper, 2 oxygen, and 1 carbon. So what I'm going to do is I'm going to start by picking one of my elements that's not balanced. I'm going to pick oxygen just because it looks like oxygen is bound to both copper and carbon. So I'm going to pick the one that's bound first instead of the ones that are by themselves first. It's a little trick I find that really helps with the balancing process. So here on the left side I have 1 oxygen, so I'm going to multiply that by 2. and I'll end up with 2 oxygen and 4 copper. And on the right side, I'm going to multiply my copper by 2. Oh, sorry, not 2. I'm going to multiply it by 4. And now it looks like everything is balanced. So I have 4 coppers on both sides. I have 2 oxygens on both sides, and I have 1 carbon on both sides. So therefore, this is a balanced equation. All right, last but not least, I've got this hydrogen peroxide, and it's becoming water and oxygen. So first I count how many I have on the left. I have 2 of each. And then I count how many I have on the right. I have 2 hydrogen, and I have 2 oxygen, but I also have an oxygen in the water, so I have a total of 3 oxygen. So everything looks like it's balanced except for oxygen, so I'm going to start on the right side with my oxygen. Once again, noting that on the left side I have to have an even number of oxygen and hydrogen, so that means I should put an even number in front of my water molecule so that I can make sure I have an even number on the right side as well. So now I have a total of 4 oxygen and 4 hydrogen. And in order to balance that on the left side, I'm going to put another 2 in front of hydrogen peroxide. So I have 4 and 4, and now it is all balanced.